Classroom, Bill Keneely here today alongside Mike Bono, and today's topic dealing with dew point and relative humidity. We'll talk about the variations in the seasons and climatological variations between, say, a desert as well as, say, a very temperate zone, the humidity areas of the eastern seaboard. In addition, we'll talk about the weather history right now, and it was 10 years ago today, May 3rd, 1984, a very powerful tornado ripping on through Montgomery, Alabama. Unfortunately, right at the height of the morning rush hour, and 5 people were killed, 37 injured, and some of those fatalities occurring, I believe, along Interstate 85. The tornado rated an F3 on the Fujita scale of 0 through 5.
Here at the Weather Channel, we're always talking about relative humidity. You might wonder what that's all about. Here's Jeanetta Jones to explain.
To most, relative humidity is defined in terms of how comfortable or uncomfortable it feels outside. Relative is the key word here. As the phrase suggests, it relates the actual water vapor present to that which could be present at a given temperature. It's expressed in percent. A temperature of 80 degrees with 96% relative humidity means the air is holding 96% of its moisture capacity at that temperature. So why doesn't 96% humidity in the winter feel as unpleasant as in the summer? Because temperature largely determines the amount of water vapor air can hold. Warm air can hold more water vapor than cold air. When it's cold, air molecules are huddled close together. There's no room for moisture to be absorbed into the atmosphere. When the air temperature is warm, molecules are spaced farther apart and moisture is easily absorbed. The more saturated warm air is, the more uncomfortable you feel. That's because body sweat isn't easily evaporated on damp days. Your body's ability to cool itself is being inhibited by the weather. Jeanetta Jones, the Weather Channel.
Again, our topic today dealing with relative humidity, and simply put, the relative humidity is the amount of moisture in the air relative to the amount of moisture the air can hold at a given temperature. So a couple of examples here for you now. Air temperature, for instance, being 75 degrees, say the actual dew point temperature, the temperature at which that saturation occurs, is 52 degrees, makes the relative humidity running at about 45%. In another scenario, it's a little more humid this time around. The air temperature is 75, the actual dew point temperature is 72. This is something you see a lot in the southeast, especially in the morning in the summer times. That makes for a very high relative humidity of around 91%. We'll take a break. We'll talk about the differences in wintertime as well as in the desert locations right after this.
We're at the height of the severe weather season right now. Last week, tornadoes touched down in many parts of the United States. For today's story, we'll take you back to 3 of the deadliest tornado events in our history.
The Xenia, Ohio tornado, April 3rd, 1974. There were 148 tornadoes that same day in the eastern half of the U.S. That's one of 3 killer tornadic events we'll discuss in this report. We begin with the deadliest twister, known as the Tri-State tornado, March 18, 1925. 695 people were killed. This rare film shows the destructive power which reached the maximum conceivable rating of F5. The Tri-State's tornadic winds were estimated at up to 300 miles per hour. In Illinois, the town of Murfreesboro lost 234 souls to the winds, the most of any town in U.S. history.
Scientific thinking is now that perhaps, we're not sure, but perhaps the Tri-State tornado was actually a series of violent tornadoes, but moved along the exact same path to give the appearance of one single tornado.
In the afternoon of June 9, 1953, in Worcester County, Massachusetts, the sky grew dark and large hailstones began to fall. A Category F4 tornado touched down in Petersham and didn't disappear into the clouds until it had traveled 46 miles, killing 90 people. The damage totaled more than $52 million.
Usually you think of violent tornadoes, F4 and F5, as being in Kansas and Oklahoma in the so-called Tornado Alley. But this was in Massachusetts, and it's very unusual to see a tornado of that violence in the New England area.
On April 3rd and 4th, 1974, 148 tornadoes touched down from Mississippi to upstate New York. It's known as the super outbreak, killing more than 300 people and injuring 5,000. In Xenia, Ohio, this F5 tornado traveled 32 miles and killed 34 people. In Wilberforce, the Xenia tornado caused $7.5 million in damage to Central State University's campus. Students returning to campus were in shock.
That tornado has been very widely studied from the damage that it caused and the very good film that we have of it. And there is a chance that could be one of the most violent tornadoes ever. Even for an F5, it was extremely violent.
We look at the pictures of the horrible destruction in Murfreesboro, Illinois, so many years ago. And we know that throughout our history, tornadoes have ravaged the American landscape. We also know that they always will. I'm Charlie Welch, the Weather Channel.
In order to get a better explanation on dew points, the Weather Channel's Keith Westerlage got out a couple of sponges. It's an effective demonstration, but you might want to wear rubber boots while you watch.
Let's take a look at a typical dew point map. Up to the north, we have colder dew point temperatures in the 30s, yet down to the south, dew point temperatures are much higher in the 60s in Texas and Florida, and even 70 degrees. That's very important in weather forecasting because, first of all, a higher dew point makes it more uncomfortable outside. Also, a higher dew point means the potential for heavier rain. Now, if we look at the atmosphere as a sponge, you can see a small sponge represents colder weather. A big sponge represents warmer weather. So we take both of these sponges, stick them in water, and what happens? Well, you pull out the small sponge, a cold atmosphere, and it can only hold so much moisture. Whereas on warm days, the atmosphere, like a big sponge, can hold a lot of moisture, and therefore, you can potentially get more rain. That's why it's important to know what dew point temperatures can mean.
Our closer look today focusing on, again, the differences between relative humidity and dew point. And let's take a look at a presentation that we often use of dew point here at the Weather Channel. This is what we see on the Gulf Coast as the dew points go over 70 degrees, the dark green, and then in the 60s, the medium green. We often talk about dew points. This is a moving loop, we call it, going back over several hours. Now, what do these dew points mean? Let's take a look at a couple of thermometers right now. And notice that you can have snow or rain or freezing rain at 32 degrees with the dew point being just 32. That's because the temperature is also 32, and that means the air is holding as much moisture as it can hold in the vapor state. Once you reach even temperature and dew point, you reach 100%, and it usually comes out as water. On the other hand, out in the desert, the temperature may be 115 and the dew point even higher. This air actually has more water vapor in it, but at 115 it can hold a lot more. So since it can hold so much more, the relative humidity turns out to be only 8%, even though the atmosphere has more water vapor in it. However, at 32 degrees dew point and temperature, it can only hold just so much. It's cold, and the relative humidity is 100% or saturation. For more about dew point and humidity in the weather classroom, water in the atmosphere.